Hello, my name is Leandro Doctors. I'm from Argentina, from a small town in Argentina called San Juan. I'm very happy to be here today to present a proposal, well, an idea, to combine 3 areas of software construction or software engineering, as some people prefer to call it. These areas are systematic software design, domain-driven design, and contract-driven development. Basically, we will start from a variation of the design recipes from the book How to Design Programs, and we will integrate those recipes with other sources, so we can, as I said, combine those 3 worlds. It is very useful that in this case we can count on Clojure spec to take care of the specifications and the generative testing part of this. So, first of all, I'm here today to share some insights and receive yours. This is not something, this work is not something I have done on my own. As it is stated here, it's a joint work with Diego Sanchez. We presented a workshop version of this talk a year ago in the Bob conference in Berlin. Again, the idea is to share and gain insights. So it's a two-way street. So I'm not here to present you with something that will solve all of your problems, but maybe it can help tackling a few though. Plus, the tools we propose using are just the best means we could find. Perhaps you can find others and that suit you better. That's fine. So, as we don't consider ourselves experts, not in Clojure, not in Clojure spec, there may be a chance or approach to coding can be improved. So please feel free to suggest any improvements that you think we could do. So that would be nice. So to sum it up, just take what we have to say with a grain of salt. And of course, we will be more than happy to receive your feedback. So thank you very much. As I said, we will combine 3 areas of software construction, also known as software engineering. The first one is systematic software design, which basically means to carry out the software design process using a plan, order, procedure. This approach can be implemented via design recipes, which is stark contrast with the tinker until it works approach we normally use. A design recipe is a set of development guidelines divided into baby steps, and all of them share a single design process. We adopt and adapt the design recipes presented in the books How to Design Programs, so we can suit it for test-driven development. We also like to, we also want to take some parts of what is called domain-driven development, domain-driven design, which means basically to focus on our problem's domain and its logic rather than on the technology we happen to use right now, even if we really, really like it. And also to base ourselves on a model of that domain, expressed in a ubiquitous language, shared across all the stakeholders of the project. The third area we are interested in is contract-driven development, which basically means TDD, test-driven development, minus writing the test cases. So the idea is to be able to derive tests from a possibly partial specification, which is called a contract. In our case, we will use the power of clojure.spec to implement those contracts. So we mentioned design recipes and their steps. Let's quickly see what those steps are. These are the 6 steps of the basic design recipe from How to Design Programs by Felsenstein and others. As you can see, they cover the whole development workflow, end to end. So we simply exchange the order, we switch the order of the 2 last steps to adapt it to a TDD workflow. All of the, aside from that, it's the same recipe from the book. So let's use the theory to solve the problem. So it's a very simple problem. So to compute the area of a square, probably most of you are thinking, hey, what a silly problem. I learned how to do it in primary school. Why is this guy asking me to solve this little thing instead of a more complex problem? Well, just bear with me for now. So we will be able to focus on the problem solution by keeping things simple. So the first step is to move from the problem analysis into data definitions. In this case, clojure.spec is extremely useful. We need to, in this case, define 2 entities, which will be the side length and area. And we will simply consider them as natural numbers. So it's quite straightforward, really. The following step is to specify in a high level or function. On the left side, you can see the way we would do it without clojure.spec. When we add clojure.spec to the mix, we can define both the arguments, the return, and the signature of the function in a very formal way. So by using this tool, we are able to create a system that in a way will test itself, and that's really powerful. The following step of the recipe is to get some examples of how our system would work. So given a length of 2, we expect a square area of 4. Given a length of 7, we expect a square area of 49. So that's quite straightforward, really. So the following step is to define a template for the function, which basically means without clojure.spec, this can be much more important than now, because as we have already specified the function, in a way we have already done it. So we know that we will have a function called area of a square that takes the length and does something to the length and returns the area of the square. After we have defined our examples, we can do some testing. So it's very straightforward once we have already defined the examples. So that's very straightforward, as I said. So we simply define the test that correspond one-to-one to the examples. Of course, when we use clojure.spec, we can add the automated and generative testing to the mix. So we don't have to rely on individual tests. Rather, we can simply exercise the function. And as long as the exercising works, we are okay. There can be there can be done much more with a test check, but not in the. I haven't shown this in this example. Sorry, I have a video problem. Okay. Anyways, you will see me now watching, looking up, because my other screen on top of my head, and my primary screen is not working at all. So I will have to directly look at the presentation. So we added these stable and unstable annotations because we noticed that there might be some problems when running many tests when we have a CI infrastructure running. So in this case, we can specify which tests we may want to skip. In this case, the unstable ones, and we can simply focus on the stable ones. So the sixth and last step of the recipe is the definition, which is the actual coding. Of course, in this case, the example is trivial. But when we extrapolate and see that these very same steps are very general, so they can be applied to basically any kind of development. So it can start with a simple function, like in this case, but it can also evolve into a system with multiple functions and multiple components. Actually, in the book, there are specific recipes for different cases, and they are very, very useful. It really helps a lot. It systematizes all the thinking part of the development process. So, and then we get to the second part, the second subject of this melange, which is domain-driven design. Domain-driven design basically means to focus on the domain we are working on, instead of focusing on the tools, and not also focusing on the domain, and of course it's logic, but also focusing on building a model of that domain, and we will use that model to, of course, represent it and solve a problem. The advantage of doing this, instead of simply starting to solve the problem without a general outline, is that as we identify our core domain and also the core of our domain, we will be able to quickly identify the most stable components of our problem. So we can start by defining the most stable parts of our system. So that's a very important thing, because later on the delivery mechanism and the interfaces can change, but in the end, the nature, the essence of our problem will always remain the same, even though, of course, it will evolve over time, and it will surely change. We have a challenge here, which is how can we express this domain that we are working on? Well, we have to develop a very special element to express that, which is logically a language. What is called in the literature as a ubiquitous language. Why ubiquitous? Because it has to be shared across all stakeholders in the project, not only the developers. Plus, the developers will become domain experts in time. And as I said, it's a language that evolves over time, so it can change. And then there can even be dialects of that language. As I said, the third element of this triad is contract-driven development. And contract-driven development basically needs that our system is able to verify these definitions that we transform into code, so it can check itself. In this specific case, as we are using Clojure and Clojure spec, it's really straightforward. It's amazingly useful in order to implement this. So, going back to our problem, the main entities that we can identify are quite simple, and we have already defined them actually, which are the site length and area. And in this case, they are simple natural numbers, but as you know, if you are used to Clojure spec, there can be very complex data definitions derived from specifications. So this is a very minimalist example, but we can see here that which are the benefits of using of counting on these tools. When we talk about a problem, a situation that we have to solve, and we in the beginning talked about our data, we have to define our data. In this case, specify or formally specify our data. But data itself does not bring value. What actually brings the value in are the transformations in our system. So we take an input and we generate some kind of output, and that transformation is what brings value to our client. So of course we have to model those transformations. In this case, we have only one transformation, which is the main function, which will take the length of the square and eventually will return the area of the square. In this case, the area of a square is simply the square of the length of the side, but if it was a more complex geometric figure, the formula could change. But in both cases, the specifications would be extremely helpful. Of course, not all transformations are seen in a way or perceived by your users. The ones that are actually perceived by our users are called events. So they're a specific type of transformations. So in this case, the function we wrote doesn't have a UI or a text user interface even. So so we could we could have more functions to build that interface. So they would be able to present the internal transformations to the user. So we always have to be very mindful of these events, as they are the ones that will provide the services that we are building. So you have to pay attention to that. Again, we have to identify our core domain and also the core of our domain, of our problem. That core will include the main entities of our domain. Entities could be constants, or could be business rules, or could be simply specific data. That depends on the problem. In this case, well, our entities are quite simple. We have already defined them. As I said, they tend to remain stable, so that's a huge advantage of focusing on the core domain in the beginning, and leave the delivery mechanism, either a text user interface or a graphic user interface or a REST API or a GraphQL API for later. Of course, every service that our application provides must convey the value to our clients. So they have to provide the value generated by your events. As I said, we haven't invented the wheel. We are simply reusing information from other sources and adopting it and adapting it. So we can recommend a few sources. Firstly, how to design programs. That's the book that includes the design recipes. It's been written by staff of mainly, I think, Northwestern University or Northeastern, I don't remember right now, in the US. And they have been using this technique, this method, for over 20 years. So they know a thing or two about that and its practical application. Of course, when we go to domain-driven design, there is also the book of Evans, which is the original one, but this one is not, that one is a book from Scott Millett and Nick Tune. We prefer this book because it's an evolved version of the first one. So I think it's better organized, but of course you can refer to the original book. It's up to your taste. Another very useful influence was the book by Scott Blashin, Domain Modeling Made Functional, where he makes this fusion between domain-driven design and functional programming. In his case, he uses the type system of F# to achieve what he calls a very readable formal language, in a formal specification language, as the type definitions in F# are very easy to comprehend to non-developers. That's very important. On our side, we can, of course, use Clojure-spec. And I think that even though Clojure might not be so easy to understand to some people, its syntax, even though it's simple, it's not that difficult. It's simple after all, it's just different. And we have the power of Clojure spec, and that's much richer than a type system that any type system can be, as we can compose and construct quite elaborate specifications, as they are executable. They are great for verifying compliance with the domain restrictions that we have. And finally, this paper about contract-driven development is the formal definition. It's by Leitner and others, and among the others we have Bertrand Meyer, the inventor of Eiffel. So a very very influential person. So thank you very much for your time. I hope this talk hasn't been too theoretical, and I hope that you apply this approach to solve your problems. And of course, we count on your feedback to see how well can we combine these approaches with a tool such as Clojure spec, so which is extremely powerful. So thank you very much, London Clojurians, specifically Bruno Bonacci, who invited us, actually, because it was Diego and me who were invited. Diego couldn't make it. And also to Dayo Oligide, who is now hosting this meeting. We are looking forward to your questions, and thank you very much for your time.